Hello everyone. Samantha Pepa, second year student, Makerere University, pursuing a bachelor's degree in software engineering. I've come again to talk about the laptop price predictor model, which is an AI model. But before I start talking about it, I kindly request to subscribe to my channel, as a new channel, and then to like my video. I really appreciate if you do that for me. As I start, first of all, talking about the real life problem that this laptop price prediction model is to solve. And this says that this project aims at solving the challenges people face in finding the exact kind of laptops they need to solve their everyday problems in work, studies, leisure, like the games, because not every machine can do certain tasks. And the user can be there knowing what he or she wants, but doesn't know how much he or she needs to get that exact piece of laptop. And this is where the laptop price predictor system or model comes in to solve this kind of problem. And furthermore, as I go further, this brings about a lot of opportunities for frauds as other people with negative intentions to take this as opportunity to overcharge many different people such that they give them what they want. So many people take this as an opportunity to overcharge, like someone might be wanting a laptop but doesn't know the price or in which this laptop is, but then someone comes out of nowhere and charges him or her highly as compared to the exact amount this laptop should be at. So them a laptop of 700,000 at 1.2, which is not good. And this is where the AI model or the laptop price prediction model comes in. So this project is to help users who know what they want to plan for how much they need by outputting the price of the exact laptop depending on the user's specification. So this system, as I talk about it further, it prompts the user to input the specs or details of the laptop he or she specifically wants to use. As a result of the user putting in these things, the system outputs the price of that exact laptop that is needed by the the user. The dataset application to the LPP that I used, it says the dataset to be used in the project has defined details from which output is got after the user inputs the details of the exact laptop he or she wants. The dataset used has many different columns which include the company, the type, the product, the CPU, the screen size of the laptop, the screen resolution, the RAM, the memory, the GPU, and many more. And all these are necessary for the user or the pre-user of the system to specify before he or she gets to know the exact price of the laptop. When the user inputs these specifications of desired interest, like Dell company, someone can be interested in a Dell laptop, and the model is listed on 3340 as the product. Then a notebook type, we have different kinds of types of laptops like notebooks, workstations, ultrabooks, convertibles, which is 8 GB RAM, 512 GB SSD, and then the laptop price will be able to give back the price of that exact laptop based on what the user has previously inserted into the system. When I talk about the feature selection, this is the method of reducing the input variable to your model by using only relevant data and getting rid of noise in the data. So this feature selection helps us to remove unwanted or unnecessary features in the dataset that we have to use, such that we make the dataset apply to the exact problem it has to solve in the AI project we are working on. And it is the process of automatically choosing relevant features for your machine learning model based on the type of the problem you are trying to solve. And this selection increases the selection power of the algorithms, which increases accuracy. So mainly, feature selection helps us mainly on the accuracy of the project. It helps us to achieve that point of accuracy of the system. And there are two main types of feature selection, which include, first of all, you have the supervised feature selection technique, which is one, and this mainly deals with labeled data, like as the one we are going to use this laptop price predictor, and you kindly check in my description where I will put the link to the data set to use for this project. And then you also have the unsupervised feature selection technique, which deals with unlabeled data, unlabeled data generally. Factors are considered for the data sets. First of all, the size of the data set. This size of the data set should be enough to satisfy all the users' inputs of details of interest. And we have the company column. It is also a must as we are dealing with laptops which have different companies, some manufacturers. So this specifies the brand of the laptop from which other small subsets of the details are to be selected from as a result of the user's input. So also have the CPU column, which includes like the i3s, i5, i7, which one you need as a user. And this gives the processor power of the exact laptop certain user of the system is interested in. We also have the price column, which is one of the most important features in the laptop price predictor model, since it tests the accuracy of our model. So this is where we test the accuracy of our model. And our model is able to retrieve or give us back the price of that laptop of using the inputs we put, or using the input the user or the preuse of the model we have put into the system. So we also have what we call Bayesian theorem and machine learning. And the Bayesian theorem states that the probability of an event given the new information received is proportional to the likelihood of seeing the new information multiplied by the prior information. This briefly helps us to determine the probability of an event with random knowledge. So by the Bayesian theorem already is something when you have the helping us to find the probability of the system, whereby we have already evidence on that system. We already have some given data about that. The Bayesian theorem is given by the formula written below, which is from the theorem we have posterior, which is the likelihood multiplied by the prior over the evidence. So the P, this is probability of x given y, which is the posterior, is given by probability of y given x, which is the likelihood multiplied by the probability of x, and that all over the evidence. So probability of y given x is the likelihood, probability of x is the prior, and the probability of y, which is at the bottom, is the evidence, or what we can call the marginal probability in this Bayesian theorem. Bayesian theorem, as I continue more, the above equation is Bayesian theorem. According to the theorem, both events x and y are independent events. X and y are independent events. The x and y are independent events, and which means that the probability of outcome of both events does not depend on another. So probability of x is called the posterior, as I have explained. Probability of y given x is called the likelihood. It is the probability of the evidence that the hypothesis is true. So yeah, so by the way, the probability of x given y can also be called hypothesis in this theory. And then probability of x is called the prior probability, and probability of y is called the marginal probability. And we also have the naive bias, which is a classifier under Bayesian theorem. And this is the supervised learning algorithm based on the Bayesian theorem, as I've told you, used for solving classification problems. It is a probabilistic classifier, which means it predicts on the basis of probability of an object. Some popular examples of this algorithm include spam filtration, we have sentimental analysis, and we have classifying articles. And this algorithm assumes that the accuracy of certain feature is independent of the occurrence of other features. That is what this algorithm assumes. And this is the reason why it is called naive bias. And as I talk more about the naive bias, this theorem is one of the first and easy machine learning algorithms to predict a class of data sets, and it is the most important choice for text recognition. So this applies more to text recognition. And this algorithm works particularly well with natural language processing, plus this algorithm works under assumption that each feature makes an equal and independent contribution to the outcome. As I go further, we have the Bayesian networks. A Bayesian network is a probabilistic graphical model. This is just a model which represents a set of variables and their conditional dependencies using a directed cyclic graph. Bayesian networks are probabilistic because these networks are built from a probability distribution, so they are probabilistic because they are built from probability distributions, and also use probability theory for prediction and anomaly detection. And the Bayesian network can be used for building models from data and experts' opinions. It consists of two parts, which parts are the causal components and the actual number, and that is the Bayesian. That is the Bayesian network graph, which consists of nodes. As you can see, the nodes are the A, B, C, and then the axes, they are like the links that join these nodes, and that is the Bayesian network. So as we go further, we have the differences between the Bayesian theory and the naive bias. First of all, Bayesian theorem assumes dependence in the features, while naive bias assumes conditional independence. Bayesian theorem helps us infer probability of a particular model, while naive bias prediction model that assumes all the features are independent. It assumes all features are independent. And then the Bayesian theorem states the relationship between the given distribution and conditional distributions, which is direct proportionality and reverse proportionality, whereby the product of the prior and the probability of y given x is the direct proportional, and then the down one is the reverse proportional, whereby the Bayesian the naive Bayes is just a simplification of the Bayesian theorem by assuming y is conditionally independent of the sample space given x. Differences between naive Bayes and Bayesian network. Naive Bayes assumes conditional dependency, while Bayesian network allows the user to specify which attributes should be independent. Naive Bayes used in spam filtration, while this one is used in building models from data and experts' opinions. And the naive Bayes is an algorithm based on Bayesian theorem, while the Bayesian network is just made up of the network as just a network. It's made up of acts that join the links, that join the nodes. So these acts are like the links. And as I conclude, these are the references that have helped me come up with this presentation as I have shown it to you, whereby you have the vertical point and everything. That's all currently about the laptop price predictor model. And as I've said, I'm going to put the link to my dataset in my description on YouTube. Thank you so much.